At Voxeljet in Canton, Michigan, if you can dream it, they can probably print it. Voxeljet specializes in additive manufacturing, a process similar to the 3D printing you may have done at home or school. But here they do it with extreme precision and on a scale you have to see to believe. Join me as I learn how to turn a computer model into an actual tangible object. And listen in as I talk with Aaron Howard and Michael Dougherty to discuss career opportunities with this technology. Can you tell me about Voxeljet?
Yeah, so Voxeljet's a additive manufacturing company. We've been around coming up on 25 years. We're very focused on industrial printing.
You said additive manufacturing. Can you tell me more about that?
Additive is building a component up layer by layer. So traditional ways of making things was taking something solid and cutting it to make what you want with a mill or a drill. Additive starts with nothing and builds a layer up to make the shape that you're looking for.
To learn more about additive manufacturing, Sales Engineering Manager Aaron Howard shows me Voxeljet's expansive operation.
This is the VX4000. This is the world's largest production printer. This is a 4-meter long, 2-meter wide, 1-meter deep platform.
So you gave me this. Can you tell me a bit more about it? I can stretch it and pull it and stuff in it.
Sure thing. This was printed on the VX1000, which is our trade name for our machine. And the material is polyamide 12, which is in the amine family, or in the States it's known as nylon. Obviously is very fluid, right? So this can be used for lots of applications, whether it be conformal seating, where we have heating cooled seats, jokingly I wore it earlier as a stole. So this is a reality that will become the future very soon, is that this can be clothing and it's very useful and tactile.
Using fine particulate substances, Voxeljet's printers create products that are extremely durable and yield little waste. So you said that you tried to recycle as much as you can. Can you tell me more about it?
We try and reuse as much of the material as possible, and the build box even has an unpacking station with a downdraft table included. So this is a very fine material, and you can see it behaves almost like a fluid in this state. But the other part too is, as we unpack this, we're able to recover that material, and it just goes down into the downdraft table, and under air gets put back into the machines again.
What type of person excels in this field?
Because it's engineering related, I think problem solvers do well. Thinkers, doers, people that like to tinker and play with things, this is a good spot for them to find a good home in.
I find this really interesting. Is there a way I can take a stab at it?
Absolutely. You're welcome to make your own part today.
Thanks.
Would you like to go?
Yeah.
So now you can see where the magic happens, and you can make your own part today. I have a computer set up here for you in Autodesk NetFab to create a tool. We largely serve the metal casting industry, so we want to make a part, but we need to make the tool that makes the part, not the part itself. So we're going to make a car. Click here. So this car is about 6 inches, right? So here is the measurements right there, but you can hold it in your hand, right? We need to make this part. So we need the tool. So the tool is just a box, right? So I have the part, I need to put some space around it to make the tool. So turn on box.
Using computer-aided design software, Aaron guides me through the steps to create a mold of the car. After placing a box around the car model, we need to add cylinder shapes that represent where the liquid metal will be poured, as well as vents that will allow steam to escape. By creating vents of different sizes, it will allow the metal to flow evenly. We also need to add supports for our tool to be carried either by hand or by machine. Next, we add a label and specify which shapes need to be hollowed. Then we create a cut through our design that will be used for cleaning the inside after it's printed. Finally, we run scripts to find and resolve errors, and it's off to the printer. If I wanted to pursue this as a career, what kind of degree would I want to go for?
Electromechanical is definitely a technical focus in the area, but we really employ all degrees because it's really about the interest level and understanding and the different types of positions in here. But to stay technical, which I think is more your interest, it's the electromechanical, maybe even computer science, automation, or robotics, those sorts of things. These are robotic automated machines, so that would fit very well.
Why is this an exciting industry to get into?
The excitement for this is that everything is different every day. While we do some repeat work, largely every job is unique and new. It's also generally very rewarding because you're helping somebody create a solution to a problem they may have. So in here printing right now is actually the positive, or the car actual, that we were making earlier. So when we made that tool, we were making the negative space to create that part that'll be cast in metal, but we're gonna make that part now to look at it in plastic.
After the car is printed, it's time to clean up.
Yep, you got it. It's really that easy.
Yeah,
We can pull that. We can pull that.
It's kind of hot.
Yeah, that looks great. You did a good job.
Yay!
It's exciting to see our digital creation in real life.
And you can take it. So you're welcome to take it home with you. It's yours. You've made it.
Really?
Yes.
Thank you so much for doing this. It's so cool. Thanks, Voxeljet. I had a blast learning about this awesome career.